In our body, we have different muscle types. I want you to think about your own experience. I'm sure you have seen some people, they are born with better ability to run a marathon, run ultra marathon, right? Those people, they just can do that. And there are people who are better in lifting heavy weight, but if you tell them to run, it's like killing them, right? So why is that? The reason is because the muscle composition in each individual is different. We have different type of muscle, and the combination of those types are different among different people. So let's learn about those muscle fiber types. The first two I want to talk about are type 1 and type 2X. Before we go further, I want you to remember this. Type 1 has a lot of mitochondria. And type 2X, they have low level of mitochondria, but more glycolytic enzymes. Okay, so for now, don't worry about anything else. Just remember this too. Look at it, remember it. Type 1 has a lot of mitochondria, and type 2 has low mitochondria levels, but it has a lot of glycolytic enzymes. And type 1 has low glycolytic enzymes, so they are kind of opposite. Okay? The reason I want you to remember this too is that it will explain all those perfectly. You don't need to memorize all this. As long as you know what mitochondria does, what glycolytic enzymes do, then you know exactly why this happens. Okay, so first, what does mitochondria do? It is where oxidation happens. So type 1 is oxidative, right? And what does glycolytic enzymes do? They does glycolysis. So type 2X is glycolytic. All right. And do I tell you that oxidation requires more time? Yeah. So it is slow contraction time. Type 1 contracts slowly, and type 2X can contract quickly because glycolytic enzymes, glycolysis, produce ATPs fast, right? Those are the things that we learned in the previous chapter, or actually previous section in the energy system, right? All right, so if you contract slowly, then you are called slow twitch muscle fibers. So type 1 is slow twitch muscle fiber. And type 2X is the fast twitch muscle fiber. Okay, type 2X is the fast twitch muscle fiber, type 1 is slow. And it makes sense because oxidation takes more time. All right, mitochondrial density, this is the major thing that you just need to remember, and it can explain everything, okay? Okay, so if you want to do oxidation, what is required? Oxygen. So what delivers oxygen? Blood. What's the color of blood? Red. So type 1 is also called red muscle. And type 2X is called white muscle. And it is not like plain white, okay? Not like t-shirt white. It is more like pinkish, okay? It's lighter in red, so we call it white muscle, okay? And then if you use mitochondria to make energy, you need oxidation, you need oxygen. It is aerobic. So type 1 is aerobic. Type 2X is anaerobic because glycolytic enzymes does not need oxygen to break down glucose, right? Glycolysis does not require oxygen to make ATPs, so it can be anaerobic. And type 1 has low force production. That's important because when you are producing force, you need a lot of ATP fast immediately for you to use. Like you are lifting something that is 100 pounds. You need a lot of ATPs in a short time, right? Oxidation does not have the ability to give you that much ATPs in a short time. For a longer time, of course, it can make a lot of more ATPs when comparing to glycolysis and PCR, right? But if you are using oxidation to make energy, it takes time. So it does not give you force that much. It doesn't give you strength, but it gives you endurance. So it's low force production for type 1 and high force production for type 2X, because glycolysis can make a lot of ATPs in a short time by using a lot of glucose. All right, if you can make a lot of energy by using a lot of glucose, that means you are making a lot of lactate, a lot of hydrogen ion that we will learn later is the reason why you feel sore, immediate soreness. All right, so type 2X fatigue faster because you can deplete the glucose or glycogen faster because you need a lot of them. Every one glucose can only make 2 ATPs. You're gonna use a lot of them to lift that 100 pounds, right? So you are going to fatigue fast. And type 1 makes energy from fat. And remember what I told you earlier? That fat can produce a lot of ATPs, right? You just need to give it time. So type 1 does not fatigue fast, so it's slow fatigue. And sometimes we say fatigue resistant. Okay? All right, so let me clear this. And let's look at this guy, Captain America. These are his superpowers. He has big muscle, he fights hard, he fights for a long time, he can run fast. At the same time, he can run for a long time, and he jump pretty high. So right now, let's think about what kind of muscle type does he need to achieve each of them. So for big muscle, I forgot to tell you that type 2s are bigger than type 1. So type 2X gives him big muscle. He can fight hard. So if you want to fight hard, he needs strength, he needs power, he needs to generate ATP in a very short time. That means he needs type 2X. He can fight for a long time. That means he needs oxidation to create a lot of ATP for a longer time, but it does not give you that much ATP at the beginning, right? So type 1 does that. That's for endurance. So run fast, again, immediate energy at the beginning, right? So you need to make a lot of ATP immediately, fast, so type 2X. Run for a long time, again, type 1 for aerobic system, right? And he can jump high. That means he needs power, so ATP a lot at the beginning, so type 2X. So I want you to think about this. Type 2X is good for strength and power, and type 1 is good for endurance. And they are providing these spatial characteristics for a person. All right? But this guy is Captain America, right? So in his body, he has both strength and endurance. Strength and endurance. So you would think, okay, so strength, he has this, right? So if you have his arm all type 2X, he can fight super hard. But can he fight for a long time? Nope, right? So he has to fight for a long time. So let's change this to type 1. Uh-oh. He can fight for a long time, but he cannot fight hard. So what should we do? Combine, right? Some muscle fibers are type 2X, some muscle fibers are type 1. So if he combine type 2X and type 1 in his arms, he would be like a good fighter, right? Like you see on TV, those fighters, right? But can he be Captain America? Probably not. He probably would be a good athlete for strength and fighting, right? But probably not as good as Captain America. So can we have a muscle that has both strength and endurance. If every single muscle fiber in his arms is the muscle that has both endurance and strength and power, okay? Strength and power, they kind of come together. Then this person can be a superhero, right? So, do we have that? I want to introduce the third muscle type. It's called muscle type 2A. Okay, so we have type 1, type 2A, type 2X. And I put type 2A in the center. There's a reason for that. Because it is the combination of type 1 and type 2X. In order to explain what type 2A is, I like to draw the muscle cells. So let's say these circles are muscle cells. And type 1 has a lot of mitochondria. So these are mitochondria. And type 2X has just a little bit. All right? And type 2X has a lot of glycolytic enzymes. Type 1 has a few. Okay? So what about type 2A? I said they are combined or in between, right? So type 2A also has a lot of mitochondria. Probably not as much as type 1, but still close to type 1. And it also has a lot of glycolytic enzymes. Again, probably not as much as type 2X, but still close to type 2X. So the mitochondria gives you endurance because it does aerobic metabolism, right? And the glycolytic enzymes gives you strength because it does anaerobic. All right? Okay? So mitochondria does oxidation, glycolytic enzymes does glycolysis. So it's oxidative glycolytic. And because it has a lot of glycolytic enzymes, so it contracts fast. So it's fast twitch. And it has high mitochondrial density, so it needs a lot of blood to deliver oxygen for oxidation, so it's red. And sometimes we say intermediate, like it's kind of in between, all right? And it can do both aerobic and anaerobic, right? Aerobic mitochondria, anaerobic glycolytic enzymes. Because it has glycolytic enzymes, it can do anaerobic energy system, so it can produce high force. And because it has a lot of mitochondria for endurance, so it is fatigue resistant. I want you to think about your training. Let's say you play soccer or lacrosse, okay? Or baseball, basketball. So you play sports. In the training, what does your coach always tells you to do? You have to run, right? And you hate it. And your coach will tell you, you have to run for 3 miles today or every morning, right? So why? Think about when you play sports. You are not just going on the field and then just kick the ball and then leave, right? Or shoot the ball and leave. You don't do that. You actually stay in the field for maybe 30 minutes, 40 minutes. And if you are good enough, your coach will keep you there forever, for the whole game, right? So if you are playing sports for more than 30 minutes, 40 minutes, maybe 1 hour, then you require endurance. So your coach will want to train you for endurance because your sport require endurance. So if you have a lot of type 2X, let's say you're born with a lot of type 2X and you have strength. You can shoot the ball very well, very hard. You can kick the ball very hard. You can run super fast. But you still need to stay in the field for a longer time. So you train for endurance. Then your type 2X will start to produce more mitochondria in the cell. So if you add more mitochondria in the cell, what does it become? It becomes type 2A, right? you add mitochondria to type 2X, then you create type 2A. So with training, you can switch type 2X to become type 2A. And what about a person who has a lot of type 1 muscle fibers? So that person also plays sports. And besides running, he or she needs to kick the ball hard, shoot the ball hard, right? In many cases, he or she needs to run super fast. So type 1 muscle fibers will start to create a lot of glycolytic enzymes. And if you add glycolytic enzymes into type 1, what does it become? It becomes more like type 2A. Okay, and I want you to look at these arrows. I intentionally draw the arrow between type 2A and type 2X more solid, and type 1 and type 2A more transparent or lighter. Because in human body, we see type 2X turning to type 1 more often. And type 1 turning to type 2A not that often, unless you train very hard for endurance. Otherwise, you don't see type 1 turning to type 2A that often. Type 1 will become more like type 2A, but it does not really switch to type 2A that often. And the other reason is because type 1 is basically required for everyday living. So like you are walking, you are sitting down, you are maintaining your posture. Those are low intensity physical activity, right? So type 1 is required for as the base for your daily living, daily activity. So you don't really want to get rid of type 1, right? So you keep a lot of type 1 and you just make it more like type 2A, but you don't turn a lot of type 1 to type 2A. But type 2X can totally become type 2A, all right? Because they are still type 2, right? They are like the same family, right? So it doesn't really matter that much that you don't have that much type 2X, because type 2A does the same thing as type 2X, but it does extra. This table summarizes what I just talked about earlier, but I want you to look at this type 2B, all right? So sometimes you will see people call type 2X, type 2B in human body. In animal, we see type 2A, type 2B, and type 2X. But in human body, we only have type 2A and type 2X. So some scientists or some people, they just call type 2X, type 2B in human body. But don't worry about it. Type 2B and type 2X are the same thing in human body. All right, the other thing I want you to look at is this myosin ATPase activity. So what is ATPase? ATPase is the enzyme that hydrolyzes ATP to make ATP release that phosphate to release energy. Okay, so the enzyme for ATP to do this is ATPase. The higher the enzyme activity, the faster the ATP releases that energy. So on myosin, we have ATPase to hydrolyze ATP to make myosin head move the actin towards the center. I talked about it at the beginning of this session, right? All right, so if you have low ATPase activity, then you release the energy slowly, then you contract slowly. So that's the other reason why type 1 is slow twitch, okay? And type 2s are fast twitch because they have high ATPase activity on their myosin head, so they can release the energy from ATP faster, so contract faster.